Hi everyone, I am Dr.J Suresh Goud, Associate Professor in Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss about problems on multiple correlation. See, in the previous session, we discussed how to find the correlation between the two variables. Which are x and y. But now we are going to discuss the relation between more than two variables. That is called multiple correlation. We have different type of formulas to find the multiple correlation between more than three variables. Suppose if you take x1, x2, x3, three variables are there. We can find out the relation between these three variables by using the multiple correlation. Suppose a dependent variable is x1 and the remaining two are x2 and x3 are independent variables which are not dependent on x1. Then the coefficient of multiple correlation coefficient to find the relation between the three variables of x1, we can denote it with R1. We are finding multiple correlation coefficient of x1. Here x2 and x3 are dependent variables. So we can denote it with R1.23. This means R1.23 means the multiple correlation coefficient of x1 as x2 and x3 are independent variables and x1 is dependent variable. Similarly, suppose if I write R2.13, this is called multiple correlation coefficient with x2 as dependent variable, x1 and x3 are independent variables. Suppose R3.12 if I write, that is multiple correlation coefficient with x3 as dependent variable and x1 and x2 are independent variables. We have different formulas for this: R1.23, R2.13, R3.1. Here x1, x2, x3 are variables. What is R1.23? R1.23. What is the formula? Under root of small r square, small r12 square plus r13 square minus 2r12, r13, r23 by 1 minus r23 square. It is very easy to remember this formula. R1.23 means multiple correlation coefficient with x1 as dependent, x2, x3 are independent variables. Under root of, see, 1, 2, r12 square plus r1, one time 1, 2, second time 1, 3. Minus 2, remaining all r12, r13, r23. All cases you write. By 1 minus, only independent variable you write, r23 whole square. Similarly, same concept, R2.13 also under root of R21 square plus R23 square minus 2 into R21, R23, R13 by under root of 1 minus, what are the independent variables? 1, 3. So, R13 square. Similarly, R3.12 also we can write. Very easy. Under root of R31 square plus R32 square minus 2 R31, R32, R12 by 1 minus R12 square, because 1 and 2 are independent variables in this case. Right? So, this multiple correlation coefficient is always non-negative. It values between 0 to 1. The R value or multiple correlation coefficient value always between 0 to 1 only. Suppose if I consider one problem, a single correlation coefficient between yield and temperature, similarly rainfall. We are going to find out the correlation coefficient between yield, temperature, rainfall. Three variables are given by R12 is given 0.6, R23 is given 0.8, R13 is given 0.5. Find the multiple correlation coefficient. Here, we don't know which one is dependent and which one is independent. In that case, you can take directly R1.23, multiple correlation coefficient with x1 as independent variable, x2 and x3 are dependent variables. And we know the formula of multiple correlation coefficient equal to under root of R12 square plus R13 square minus 2R12, R13, R23 by under root of 1 minus R23 square. And you know that all R12's value, R23 value, R13 value. R12 which is 0.6 whole square plus R13 0.5 whole square minus 2 into 0.6, 0.5, 0.8 by 1 minus R23 square 0.8 whole square. We'll get capital R equal to capital R 1.23 equal to 0.6. This means multiple correlation coefficient with x1 as x1 as dependent variable and x2 and x3 are independent variables. Similarly, if R31 value is given, R32 value is given, R12 value is given, we need to find out R3.12. See, R3.12 means multiple correlation coefficient with x3 as dependent variable and x1 and x2 are independent variables. Formula is R31 square. According to this one, we can write the formula plus R32 square minus 2R31 R32 R12 by 1 minus R12 square. R31, R32, R12 values, we know that. If you substitute in this formula, we get R3.12 is 0.7. So, you should check the value. R value is always in between 0 to 1 only. Now, give the following data, compute multiple coefficient of correlation of x3 on x1 and x2. See, we need to find out capital R, multiple correlation coefficient of x3, 3 on x1 and x2, R3.12 we require. R3.12 formula under root of R31 square plus R32 square minus 2R31, R32, R12 by 1 minus R12 square. But compared to the previous problems, directly small r values are given. What are the values? R12, R31, R32. These values are given. But here, in this problem, small r values are not given. Only x1, x2, x3 values are given. We need to find out small r values. How to find? See, n equal to, you know that 6 number of values. First you find x1 bar 8, average of all x1s, x2 bar 7, x3 bar 50. So we have to calculate these values. How to find? After getting capital X1, capital X2, capital X3, you got it. You find out small x1, small x2, small x3. After getting x1, x2, x3, you find out x1, x2, x2, x3, x3, x1. How to find small x1, capital X1 minus x1 bar? In the previous slide, we have x1 bar equal to 8. So this is 8. x2 bar equal to 7, x3 bar equal to 50. x2 bar equal to 7, x3 bar equal to 50. Now we'll see small x1, capital X1 minus 8, 3 minus 8, minus 5, 5 minus 8, minus 3, 6 minus 8, minus 2, 8 minus 8, 0, and 12 minus 8, 4, and 14 minus 8, 6. Similarly, x2, small x2, capital X2 minus 7, 16 minus 7, 9, 10 minus 7, 3, 7 minus 7, 0, 4 minus 7, minus 3, 3 minus 7, minus 4, 2 minus 7, minus. Similarly, x3, capital X3 minus x3 bar. x3 bar is 50. 90 minus 50, 40. 72 minus 50, 22. 54 minus 50, 4. 42 minus 50, minus 8. 30 minus 50, minus 20. 12 minus 50, minus 30. So, small x1, small x2, small x3 you got. Now, you find x1 square, x2 square, x3 square, x1, x2, x2, x3, x3, x1. See, x1 square, if you know the values of x1, we can find out x1 square. Minus 5 whole square, 25. Minus 3 whole square, 9. Minus 2 whole square, 4. 0 square, 0. 4 square, 16. 6 square, 36. Add them, we'll get 90. That means sigma x1 square equal to 90. Similarly, x2 square, you know that all x2 values, you can do square. 9 square, 81. 3 square, 9. 0 square, 0. Minus 3 square, 9. Minus 4 square, 16. Minus 5 square, 25. So, sigma x2 square, add them, we'll get 140. Similarly, x3 square, 40 square, 1600. 22 square, 484. 4 square, 16. Minus 8 square, 64. Minus 20 square, 400. Minus 38 square, 1444. So, we got sigma x3 square also 4008. Now, the required values are x1 into x2. You know that x1 value minus 5 into x2 value 9. Minus 5 into 9 minus 45. Next, minus 3 into 3 minus 9. Next, minus 2 into 0. 0. 0 into minus 3, 0. 4 into minus 4, 16. And 6. x1 is 6. x2 is minus 5. Minus 30. Add them, we'll get minus 100. This is which value? Sigma x1, x2. Similarly, x2, x3. You know that x2 values and small x3 values. x2, 9 into 40. 9 into 40, 360. Next, 3 into 22, 66. Next, 0 into 4, 0. Next, 0 into minus 8, 0. Now, minus 20 into x2 is minus 4 into minus 20, 80. And minus 38 into minus 5, 190. If you add them, sigma x2, x3 value minus 582. Similarly, x3, x1. Here we have x1 and here we have x3. Minus 5 into 40 minus 200. Next, minus 3 into 22 minus 66. Next, minus 2 into 4 minus 8. 0 into minus 8, 0. And 4 into minus 20, minus 80. And 6 into minus 38, minus 220. If you add them, sigma x1, x3 equal to 720. So, like this, we need to calculate all the values. Now, you should find out R12, R13, R23. We can write the formula R12. 12 is there, sigma x1, x2 by under root of sigma x1 square into sigma x simply. Like that, we can write R13, sigma x1, x3 by under root of sigma x1 square into sigma x3 square. R23, sigma x2, x3 by under root of sigma x2 square into sigma x3 square. Sigma x1, x2 we got it in the previous slide, minus 100. So minus 100 by sigma x1 square into sigma x2 square. Sigma x1 square is 90, sigma x2 square is 140. Under root of 90 into 1. So minus 0.89 R12 value. Similarly, R13 value minus 582 by under root of 90 into 4008. Like that you can find out R12, R13, R2. Now use the formula under root of R31 square, R13 square, R23 square minus 2R13, R23, R12 by 1 minus R12 square. You get 0. This value also between 0 to 1. Like this, we need to solve multiple correlation coefficient. If the values are smaller values are given or not given also we can do. So these are the exercise problems to find the multiple correlation coefficient. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.